Hey guys, this is the second half of 11.3. It is all about area of regular polygons. This is the one thing this whole sheet will be about. You need to pay attention to each step. Overall, it's difficult because there's different parts, but each part is not difficult. Regular polygons are polygons that have all sides congruent, okay, and all angles are congruent. A square, regular polygon, right? All the angles are 90 degrees, okay, and all the sides are equal lengths. Equilateral triangle, same thing, okay? And we're going to talk about pentagons, hexagons, we'll keep on going. So, but this is an idea of what? These are both essential. Okay, the center of a regular polygon is the center of the circumscribed, okay, circle. Okay, it's the center of the circumscribed circle. So I draw a circle, and I have a equilateral triangle, a regular triangle. The center of this triangle is also the center of the circumscribed circle. Remember, when it's circumscribed, each vertex is on the circle. So over here I have a hexagon, 6 sides, hexagon, okay? If I envision the circle, I'll do it a little bit lighter. This won't be perfect, I'm not good. It's easier to draw the circle, so this is going to look a little yucky. Okay, I've got a circle going around it, right? I'll just go with it. Okay. Each vertex is supposed to be on the circle. It's not perfect, sorry. Okay, if you miss, just stick it on there, okay? Each vertex is on the circle. There we go. Okay. The center of the circle is the center of that regular hexagon. Again, we said it has 6 sides, right? Now, let's jump to the radius of the polygon. The radius is also the radius of the circle. I'll say the circumscribed. Remember, circum, go around, scribe is to right, of the circumscribed circle. So, right, the center of this circle is the center of that, okay? The radius would also be the same as the radius of the circle, okay? It goes from the center, okay, to the vertex. It has to go center to vertex, okay? So this is one radius, okay? If I go from here to here, sorry, that is not a radius because it has to go all the way to the circle, okay? So I'm going to draw in all the radii of this regular hexagon. Okay, here we go. There's all my radius. Now, a central angle, okay, central angle, when we talk about a central angle of a regular polygon, we're going to say that is formed by 2 adjacent radii. So I'm going to work with just 2 that are consecutive in a row, consecutives in a row next to each other, right? Okay, those are consecutive radii. And I'm going to talk about the angle of this. Okay, so if we do that, we know that we've got 360 degrees in a whole circle, right? Whole circle, 360 degrees. I have 6 sides, right? 1, 2, 3, 4, 5, 6. I've got 6 sides, so I have 1, 2, 3, 4, 5, 6 angles. 6 sides, 6 angles. If I take 360 degrees and I divide it by the number of angles, which is also the number of sides, that gives me the measure of each central angle. So this angle, 60 degrees. 60 degrees, 60, 60, 60. All these angles are 60. So when we talk about a central angle, this is always going to be true. The measure equals 360 degrees divided by the number of angles. Okay? So we got that. We can find our central angle, 60 degrees. Now the apothem. If you take this triangle right here, I'm going to highlight the whole thing in yellow. Okay? I'm going to take that triangle out and draw it a little bit bigger down here, just so I'm good. We know that these two radii, right, they're congruent because they're each radii. We know this whole measure of this angle up here is 60. Because these are congruent, these have to be congruent. Now, I'm going to draw the area of a triangle equals the base times the height divided by 2, or 1/2 base times height. So that means I have to know the side, how long the side is of this regular polygon. I also have to know the height of this individual triangle. The height here of this individual triangle is called the apothem. It is the height of one of the triangles. Okay? It goes from, it is the distance from center to side of the polygon. So it's always going to go from the center to the side, and because it's a distance, it's always going to be the perpendicular. Every one of these triangles, this one happens to be equilateral, but they will always be isosceles because two sides are equal. So when you draw this altitude in, you are always going to be dividing those central angles. Will always be divided in half. So in this case, the whole angle was 60, so this one's 30, this one's 30, this is 90, so 180, right, for a triangle, minus 90 minus 30 is 60. Now we want to talk about the area. Remember, area means, right, the number of square units. It's always the number of square units. It's what it always is. So I'm taking this hexagon, right? And I'm saying how many square units are inside this thing. That's what I'm asking. How do I find the area? Now, if you look at it, I've got 1 triangle, 2 triangles, 3 triangles, 4 triangles, 5 triangles, 6 triangles. That's how I find the area, okay? The area equals the area of 1 triangle times the number of triangles. So in this case, I have 6 sides. I have 6 central angles. So I'm going to have 6 triangles. And I just multiply them and find the area of 1, and then multiply it by 6. This is one way to do it. Okay? That's one way. Remember, area of a triangle is 1/2 the base of the triangle, which is one side, times its height, which is the apothem. And then you're going to multiply by the number of sides. Sorry, I ran out of room. Okay? So area of the polygon is 1/2 base times height of one triangle, right? Okay, times the number of sides. Now, this is like thinking through it. Here is, I'm going to put polygon area again. I'm going to put your 1/2. Now we know that this height right here, we said is also called your apothem. Okay? Now, so that takes care of, I wrote down 1/2, I wrote down height, 1/2 apothem. If I take the base of this one triangle and multiply it by the number of sides, so if I take the base, multiply it by 6, that's just given me the perimeter. Okay? So you could do it this way, or you could think equals 1/2 times the apothem times the perimeter. Okay? This is your big thing right here. Right there. Okay? That's it. And that's what we're working to. Everything is about that. So there's not a lot of problems, but they are kind of work getting through the steps. Let's just talk about some of the basics together. In this diagram, you are asked to, it says it's a regular pentagon. Pentagon, we got 5 sides. 1, 2, 3, 4, 5. 5 sides, okay? It's inscribed in circle F. So each vertex is on the circle. Find each angle measure. It says measure of angle AFB. Walk it and talk it. Start at A, go to F, go to B. So I'm doing this angle right here. Well, that's one of my central angles. So I'm drawing the radii only. I'm not drawing this apothem, just the radii. Okay, 5 sides. Oops, 5 sides. 5 central angles. Okay, that's where my head goes. And then I go, okay, full circle, 360 degrees. This time, because I have 5 of them, 1, 2, 3, 4, 5, I'm dividing by 5. And that will give me this whole angle, right? 360 divided by 5. Okay. After you scribble, erase it in case you need to scribble more stuff. Okay. So I have found that by doing what we said. Now it says find the measure of angle AFG. So this time I'm going to start at A, go to F, but now I'm going to G. Okay, I'm going to turn my paper because I just think it's easier this way. Okay, the 2 radii are congruent, right? It's in the same circle. So these radii are equal length. So that means these angles, right? Isosceles triangles, base angles are congruent. When I draw in the altitude, it's going to be perpendicular to this side. That's what I'm doing. And these are congruent, and I'm also dividing this angle into 2 congruent angles. I'm bisecting the angle. So whatever answer you found for number 1, when I get this, I got to divide by 2. Okay? And then when you go back to your triangle, once you know this angle, you know the golden rule of a triangle is 180 degrees. You used up 90, you used up this angle. What's the measure of that angle? Okay? So that's how you do number 1. Number 1 through 3 is this picture. I try to squish a lot in here, okay? This diagram is used for 4 and 5. They're asking you find the length of the apothem. So really you're just identifying. find the length of the radius you're identifying. Now, it does ask for the length of one side of the polygon. If I use this triangle right here, okay, use that triangle, I'm going to redraw it bigger over here. 5.5 from G to F. 6.8 is from E to F. I know this is perpendicular. So to find this side here, X, you could use the Pythagorean theorem. Now be careful, because you're going to have to double it to get the whole length for the side. Okay? This, you're just naming the different measurements and naming the sides. Okay? Look in your notes, you can do that. Now I'm going to flip it over. This is just setting the stage for the hard stuff. I want to do one of these with you. Okay, let's do, I'm going to do number 14 because we already kind of started it, so it's an easier one to do. Okay, find the area of the regular hexagon, so 6 sides, 6 central angles. I'm just thinking that as I go. The length of the radius is 10, so from the center to the vertex is 10. If you need to draw the circle to help you see it, draw the circle. If you don't need it, don't do it. Okay? Now, I have to, okay, the length of the radius is 10, and the side of the hexagon is 10. So each side is 10. Okay? And this whole thing is 10. Now, to do the formula, I'm just going to go by formulas and not by the number of triangles. So the polygon area equals 1/2, instead of base times height, my height is my apothem. And instead, that gives me my height, and instead of my base, it's the whole perimeter. Okay? Apothem times perimeter. Well, my perimeter is pretty easy to figure out. I'm going to do that one first. Okay? I write the formula so that I know what I need. The formula gives me direction. So the perimeter is the sum of the lengths of the sides. It's the rim around. You total the lengths of all the sides. All the sides added together. Okay? So I've got 10, 10, 10, 10, 10, 10. So I've got 10 times 6, which is 60. That's what my perimeter equals. So I've got that one done. Okay? Now, the other thing we need is the apothem. That one's a little bit harder. Since I've already got this stuff drawn, I'm just going to turn my paper, okay? So I can look at it. So I've got it on the bottom. It's easier for me. So I've got 6 sides, so that means don't divide this in half. You've got 1 angle, 2 angles, 3 angles, 4 angles, 5 angles, 6 angles. Your number of central angles is always the same as the number of sides. So I need to find the measure of each central angle, which we did earlier. So we said 360 divided by 6. That'll give me the measure of each. So central angle, the measure of the central angle, 360 divided by 6 angles. Each angle is 60 degrees. Okay? So I'm going to go back to this triangle again, just because it's already drawn in. I'm working with this. I'm going to work with the one that has the apothem drawn for me. Okay? There I go. I know this whole angle is 60, 60. You don't have to draw these in. I'm just doing it so you can see it. So if I draw this, it's an isosceles triangle. The altitude drawn is perpendicular to the base and always forms 2 congruent triangles. This angle and this angle are congruent, so they're both 30 degrees. Okay? Both 30. I don't really need it, but I'm telling you, you might need it on another problem if you have to do trig. Now, I'm going to work with just this triangle right here, so I can find the apothem. Just that triangle. That's all I'm going to work with. I'm going to pull it out over here. Okay. This is a radius, right? The length of the radius is 10. We wrote that on there. Oh, I only wrote it on 1. So the length of the radius is 10. That's this, center to the vertex. Okay? The length of this whole side is 10 because this divides the triangle into two congruent triangles. It bisects the angle. It bisects this side. So the radius is 10, but I'm only working with 1/2 of the side. Okay? This is the height of my triangle. It's this. The height of the triangle is also called your apothem, which is your A. So to do that, you got a couple ways. This is, we set 30, 60, and 90. You could use Pythagorean theorem. Hypotenuse squared equals leg squared plus leg squared. You could do it that way, okay? Or you could do a 30, 60, 90 triangle, and on that, the long leg equals the short leg times the square root of 3, okay? You could do that also. And I always just remember that by opposite of 30 is 1, opposite of 90 is 2. I remember the number 1, 2, 3. Opposite of 60 is the square root of 3. So this would be 5, this would be 5 square root of 3, this would be 5 times 2, which is 10. So you could do it that way or do it this way. I'm guessing most of you will do it this way. Hypotenuse, 10 squared is 100, right? You have to get your apothem squared and your 5 squared. So you got 100, a squared plus 25. 75 equals a squared. So a equals, we got to take the square root of 75. It's going to be the same that I wrote just a second ago. Okay, but I'll do it this way. So on, clear, second square root 75. Uh-oh, what does that say? I did something wrong. Second square root, there we go, 75. I got 8.66. Okay. Now, if you did it 5 times the square root of 3, let's see if that comes out to be 8.66. Clear. 5 times second square root 3, 8.66. So it doesn't matter how you do it. And you could use the 30 instead and do cosine of 30 is a over 10. Like you could do it different ways. Okay? You could do sine of 60 is a over 10, however you want. But I've got your apothem equals 8.66. Okay, so we get the things that we need. We got perimeter is 60, and now we just plug and chug. Okay, so polygon area equals 1/2 times the length of our apothem times our full perimeter, which is 60. It doesn't matter when you multiply, you can multiply in any order. I know half of 60 is 30, 30 times 8.66, or you just punch it in like we got it, okay? 1 divided by 2 times 8.66 times 60 is 259.8. Okay? And this was, I didn't give you any, this would be units squared, but I didn't give you a unit. So I'm just putting units squared because it's area. And that's it. So this, what I showed you, is the logic you're going to use on all three. The hard part comes in when you're working with this triangle down here. Like on this one, I knew 2 of the 3 sides, right? I knew 5 and 10, and I knew the angle, right? So the different ways, if you know, you could do, if you know 2 sides, you can do Pythagorean theorem. Okay? But if you don't know 2 sides, let's say I only had 5, then you would have to use the trig, right? Your SOHCAHTOA, which I also wrote out on your last notes. Okay? But that's it. So this is where the details is where it gets hard to find the length of your apothem or the length of a side. But your basic job to get this done, you write the formula. So the formula helps you go, okay, I have to find the length of the apothem. I have to find the length of the perimeter. That's it. Good luck.